So yesterday we went over the mole and the mole equation. Okay, so just a quick review. Okay, a mole is a unit of measurement that gives us an idea of how many particles, okay, there could be present in a given sample of a material. All right, we learned how to calculate the molar mass of each material we might encounter, okay, by taking the atomic mass of the elements that are in it and adding them together. Okay, and then we looked at the mole equation. Okay, the mole equation says that the number of moles is equal to the mass of the material divided by the molar mass, which is the mass of 1 mole. Okay, so it sort of makes sense. If I have, this mass and this is the mass of 1 mole, dividing those things should tell me the number of moles because the grams would cancel. Is everybody okay with that idea? At the end of the day yesterday, we were talking about Avogadro's number and how it can help us to either calculate the number of molecules or the number of moles. Okay, so remember that Avogadro's number is 6.02 times 10 to the 23. That is the number of particles of any given substance in 1 mole. Okay, so if I have 1 mole of sodium, I have that many atoms of sodium. If I have 1 mole of water, I have that many molecules of water. It doesn't matter what material I have, that's the number of particles of it in 1 mole. Okay, everyone understand the significance of Avogadro's number? Okay. So, in a question where they're asking for the number of molecules or they're giving you the number of molecules, you will have to use Avogadro's number. You're either going to be dividing by Avogadro's number or multiplying by Avogadro's number. That's all you'll ever do with it. Okay? So Avogadro's number works, as we said yesterday, like 12 does for a dozen. Okay? If I tell you I have 3 dozen of something, you go 3 times 12 and you know that we have 36 of that. Okay? If I tell you that I have 48 of something, you know right away that dividing 4 by 12 tells you I have 4 dozen of that. Okay? Avogadro's number works exactly the same as that. Okay? So let's have a work through on this particular problem here. Okay? So for any mole equation question, any problem period, but even if it's in the physics unit, okay, the first thing we want to do is write down what we're asked to calculate and what we're given. Okay, so the first thing we're asked to calculate was the number of molecules. Okay, and remember that I use the pound sign, okay, to denote number, not hashtag molecules. Okay, because I get people like saying that. That's not what I'm saying here. Okay, so we're looking for the number of molecules in this question. I'm given the mass, 600 grams. Okay, so I'm given little m. And I'm always going to be given, or at least given the ability to calculate, molar mass, big M. Okay, and I'm given that in this question because they tell me the material is silver nitrate. Silver's a +1. Nitrate is a -1. That compound is good the way it's written. Okay, so we're going to have 107.87. Okay, so that's my atomic mass for silver. Okay, plus how many nitrogens? How many nitrogens in this compound? 1. Okay, so there's the mass of nitrogen. And how many oxygens? 3. Okay, that's what we learned to do yesterday. Calculating the molar mass simply means putting in the atomic masses in the appropriate numbers and adding them all together. All right, so we're going to have 107.87 plus 14.01 plus 48. That's 16 times 3. Okay, 169.88 grams per mole. All right, so I'm looking for the number of molecules. I have mass and molar mass. What can I calculate right now with mass and molar mass? I can calculate the number of moles. Okay, I can use the mole equation without even having to do any algebra. Okay, it's already set up to do that. It's already set up to calculate the number of moles. So even if I was totally lost and looking at this and going, I don't know what to do this step. You'll get a mark for it. Okay, maybe then you'll remember what to do after that. I haven't taught you what to do after that, so right now you don't remember because you don't know. Okay, but that's kind of the process we want to go through. Okay, so N equals 600 grams, okay, divided by 169.88 grams per mole. All right, so that's going to get us our number of moles. Okay, so we have 3.53 moles. I want to keep all those decimals in my calculator, okay? I'm rounding off because I don't want to write them all on the board, okay? But the proper thing to do is to leave them all in your calculator, okay? Everyone follow me there? We don't round off until we're done the whole question. Okay, so I'm looking for the number of molecules. I have the number of moles, and I have Avogadro's number. Avogadro's number tells me the number of molecules in 1 mole. So this is my number of moles. That's the number of molecules in 1 mole. What should I do with those two numbers to get the number of molecules? Multiply them. Okay? In the same way that if I told you I have 5 dozen eggs, how many eggs do I have? You would go 5 times 12. Okay? We're doing exactly the same thing here. That number represents a mole, just like 12 represents a dozen. Okay, everyone follow me there? Okay, so I would multiply these two numbers together. Now here's where it gets a little different. Okay, on your calculator, entering this number can be a little bit dicey. Okay, because your calculator wants to do order of operations. How many people have the graphing calculator, the Texas Instruments, whatever? Okay, so if you have that, okay, these instructions are for you, and then I'll tell other people how to do the other ones. Okay, so if you have the Texas Instruments, whatever, okay, it doesn't matter which one you have. If it's the graphing calculator by Texas Instruments, you can do it this way. Okay, so I'm going to take my number of moles, and I'm just going to hit times, so it puts the answer there. So that's all the decimals have been carried over. When I enter Avogadro's number, it has to be entered in brackets. Okay, so I'm going to go bracket 6.02, and then I'm going to hit the second function button, and I'm going to hit the comma. Okay, because above the comma, the second function of comma is 2 capital E's, if you see just above it here. Okay, so I hit that, okay, and then I put in 23, and then I close the brackets. Okay, that's how you enter Avogadro's number on a Texas Instruments calculator. Okay, then I simply hit equals, okay, and I get 2.1, we would go to 2 decimal places, 2.13 times 10 to the 24. Okay, that's what this E means, times 10 to the power of 24. All right, so I would write that answer like so. 2.13 times 10 to the 24. Okay, and I would say molecules, because that would be my units. Okay, now if you don't have a TI, so your other options for buttons on your calculator, okay, some calculators, like this TI, have a EE button. Okay, they actually just have a dedicated EE button. Like that. They may also, like on this Casio, okay, have a button that looks like this. EXP. Okay, those are going to be your buttons. If you're using your phone right now, the iPhone uses a double E button. Okay, if you flip it on to landscape mode, it'll go into scientific, look for EE, capital EE. Okay, those are the only two options. Okay, you either have a double E button or you have an EXP button. Okay, now everything works the same. Okay, if I am using either one of these buttons, all right, I still put a bracket, go 6.02, and then I hit either one of these buttons. Okay, whichever one my calculator has. Okay, and usually what will happen then on a calculator that's kind of like these ones with the smaller screen, it'll put a little icon up top that looks like that. Okay, and it just tells you that the next number you enter is going to be the exponent on the times 10. Okay, and so then you put in your 23, and it'll look like this usually. Okay, sometimes it'll look like this, depending on your calculator. Okay, either one of those is okay. All right, if you've got anything else, let me know, and I'll come around and have a look. Okay, everybody with me there? All right, everyone follow how that one worked? So the only extra step there, we did a mole equation calculation, the easiest one that we don't have to manipulate, and then we just multiplied by Avogadro's number. Okay? All right. This is the last way I can ask you a mole equation question, because there's only 4. Okay? So copy this one down, and then we'll walk through it together. So as we have done with all the other questions so far, the first thing we want to do is write down what we're asked to calculate and the other givens in the question. It's asking us what the mass is. So what letter am I looking for? Little m. Right? Little m is mass. So I know I'm looking for little m. Okay? And they tell me the number of molecules. Okay, so the number of molecules is 1.54 times 10 to the 25. Is that more or less than 1 mole? More. A lot more. Okay, 1 mole is times 10 to the 23. This is times 10 to the 25. That could be up to or more than 100 times more than a mole. Okay, so it's big. It's a lot. All right, and they also tell me that it is diphosphorus tetraiodide, which will help me to get the molar mass. So diphosphorus tetraiodide. All right, what do I do now? What should I do with this? Okay, that's what I was hoping somebody would say. Unfortunately, it's not what I would do, because I would do that only if it's what kind of compound? Ionic, right? This is a molecular compound. That's one of those little things that I might do, okay, on an exam, let's say, okay, to see if people are paying attention or know the rules for their molecular compounds, because that's our gut instinct. We look at that and we remember Mr. Coderre said I should reduce things, but he only said to reduce ionic compounds. Watch out. Okay, so I want to calculate the molar mass of this. So I'm going to have 30.97, right? Yeah, 30.97. Okay, and there's 2 of those. Plus 126.90 times 4. 30.97 times 2 plus 126.9 times 4. Okay, 569.54 grams per mole. Okay, if I want to get little m, what am I missing right now? missing the number of moles. I don't have N. Okay, it wasn't among my givens. But they did tell me how many molecules there are. And I still remember that Avogadro's number tells me the number of molecules in 1 mole. Okay? So if this is the number of molecules in 1 mole, and this is the number of molecules I have, how can I use these two numbers to get N? Divide, yeah. Okay, this would be like me saying I have 24 donuts. How many dozen do I have? You would go 24 divided by 12. Okay, that's what we're doing here. I'm taking the number of molecules, dividing by the number in 1 mole. That will get me the number of moles. Okay, so I'm going to take that number I had, the 1.54 times 10 to the 25, and divide it by Avogadro's number. Okay, so when I do that, they both need to be in brackets. Okay, so 1.54 second E 25 divided by, in brackets, Avogadro's number, 6.02 E 23. All right, so that's what it should look like, okay, in my calculator. Okay, so 25.58 moles is how many moles I have here. Okay. All right. So now I've got N. And I've got big M. Can I get the mass? Yes. Okay, so this would be the most involved. This would probably be like a 5-mark question, okay, because you have to do the most here. All right, so I'm going to go N equals little m over big M. I'm going to follow my rules of algebra. I'm going to do the opposite. I'm going to do it to both sides and end up with that formula there. Okay, and then I'm going to do exactly that. I'm going to take 569.54 and I'm going to multiply it by 25.58, big M times N, okay, and get the mass. Okay, and notice that each time I'm using the answer function or going up and getting the number, you might not be able to do that on your calculator. You might have to just punch it back in, but you need all the decimals when you do that. Okay, so I'm going to have 14,569.63 grams. Okay, that's 14.5 kilograms of this stuff. Okay, somewhere around 30 pounds. Okay, of this stuff. That's a lot. Okay, so this question, as I said, would probably be 5 marks, right? Here's where the marks would be. 1 mark for your givens and the molar mass. Okay, you would get 1 mark for calculating the number of moles. You'd get 1 mark for the mole equation. You get a mark for your manipulation. A mark for your answer. Okay. All right. Now, if you're looking at this and going, "Oh my gosh, I thought I was taking science, not math," that's okay. There's math in science now. That's the thing. Okay. But once you do a few of these, you kind of get the hang of it. You realize there's only 4 ways that I can ask this, and as long as you know the pattern for the 4 ways and can recognize when you need to use each pattern, you're fine. Okay? So it's just a matter of kind of pattern recognition here. Okay. I would like you guys there's 1 of each type there. Okay? So get started on those. I'll give you a little bit of time to get ahead of me, and then I'll do one, and then I'll give you a little bit of time, we'll do another one. Okay, so that's what we're gonna do today, is just work on these so we get to hang out how to do them. Okay, so on our first one here, we're looking for how many moles? So we're looking for, which letter? N, yeah, we're looking for N here. Okay, and we know that the material is carbon dioxide, CO2. Okay, so that'll be 12.01 plus 16 times 2, 44.01 grams per mole. If my mental math is right, which I think it is. Okay, and we also know the mass, 150 grams. Okay, so that would be your first mark for this question. Okay, it's a mole equation question, n equals little m over big M. I don't have to manipulate because I'm being asked to solve for n on this one. Okay, all I have to do is plug in my numbers. Okay, so that would be 150 grams divided by 44.01 grams per mole. So you'd have a mark for that. All right, so we're looking at 3.41 moles. Okay, so that could be out of 3 or 4. It would be pretty generous to give 4 for that because there's really not a lot to do there, but okay, that's what we'd be looking at on that. Okay, any questions on that first one? How many people have done the second one? Okay, I'll give you a few more minutes before I go over the second. So for number 2, okay, we are looking for the mass, which means we're looking for little m. Okay, we're told that there are 26.5 moles, so that tells us little n. Okay, or just n, I guess, 26.5 moles. And they tell us that it is cobalt 2 bromide. So that would be CO with the 2 plus charge, bromide with the -1 charge, drop and swap, and we're looking at COBr2. Okay, cobalt is 58.93. There's only one of it, so I don't need to multiply by anything, plus 79.9 times 2, that's our 2 bromines. So 58.93 plus 79.9 times 2, 218.73 grams per mole for big M for my molar mass. All right, so I'd have 1 mark for that. Obviously, it's a mole equation question, but this time we have to manipulate for little m. All right, so we're going to multiply both sides by big M here. Okay, so we would get a mark for that manipulation. All right, and then we would have our 218.73 multiplied by the 26.5 they gave me there for n. Okay, so I'd get a mark for my algebra and then a mark for my answer. So times 26.5 gives me 5,796. 0.35 grams. Okay, so just under 6 kilograms. That would be about 12 pounds worth of that stuff. Okay, so like I said, you get a mark for your math, okay, and then a mark for your answer, so that would likely be a 4-mark question. Any questions on the second one? And don't be afraid to ask, guys, if there's something that you're getting lost on, just ask, okay? All right, how many people have done 3? All right, I'll give you a couple more minutes and we'll go through. All right, let's have a look at number 3. So on number 3, we're looking for the number of molecules. So, will I have to use Avogadro's number for this one? I will. Okay? Anytime number of molecules is mentioned, either asked for or given, Avogadro's number is going to be involved. Okay? So we know that it is sodium sulfide, which will help me to get the molar mass. Okay, sodium is a +1, sulfide is a -2, so we'll be looking at Na2S, which would be 22.99 times 2 plus 32.07. Okay, 22.99 plus 32.07, 55.06 grams per mole. All right, and the other thing they tell me is mass, which is little m, 29 grams. Okay, I have little m and big M. What would my next step be? France, what should I calculate if I have little m and big M? N, that would be my next step. All right, so N is going to be little m over big M, okay, and that is going to be 29 grams divided by 55.06 grams per mole. All right, so you get a mark for that, okay, you get N, so 29 divided by that number gives us 0.526, so I'm just going to write 0.53 moles.
Stop there.
Yep.
You forgot to times the 22.99.
I did. You are 100% right on that. Thank you. So you guys you gotta watch out for me. I'm old and I forget things, I make mistakes. Don't be shy about pointing it out. I'm not gonna be embarrassed even though it's gonna go on YouTube that I screwed it up. You may. Won't be the first time I screwed up and it was on YouTube, so not a big deal. Okay, 78.05, is that better? That makes everybody happy, right? 78.05 grams per mole. And that's going to change our N here, okay, because now this is going to be that number. So we are going to have 29 divided by the correct molar mass this time. 0.37 moles. Is it okay that that came out to a decimal? Yeah, just means it's less than a mole. It's okay. All right, so now I've got N. Now I want to get the number of molecules. Okay, so if I was looking for the number of donuts in 3 dozen, I would take 3 and I would multiply by 12. So I should take this number and multiply by Avogadro's number, the number of molecules, equals N times Av's number, right? Which in this case will be 0.37 times 6.02 times 10 to the 23. Okay, so I'm going to get 2.24 times 10 to the 23. Molecules. Alright, so you get a mark for that step and a mark for that step, so that would be a 4 mark, maybe even a 5 mark if I was feeling generous question. Okay? Right with that one. Okay, let's have a look at the last one. So in this one, we're looking for mass. So we're looking for little m. They tell us the number of molecules. Okay, is 7.2 times 10 to the 23. Okay, and they tell us that it is diphosphorus pentaoxide. That stuff there, okay, which would be 30.97 times 2 plus 16 times 5. All right, so we're looking at 141.94. Okay. If I'm going to get little m, I need big M, which I have, and I need n, which I don't have. But I do have the number of molecules and Avogadro's number. So if I'm looking for the number of moles, I would take the number of molecules and divide it by the number of molecules in 1 mole. Then the molecules will cancel, and I'll be left with moles. Okay? So, because this is, like, if we're looking at units here, this is molecules, and this is molecules per mole. So when I divide, the molecules cancel, and I'm left with moles. Okay? All right. Now, because these have the same exponent, they're both to the 23, do I need to put the 23s in there? Okay? If you're not confident with that, just go ahead and put the 23s in. But if you know your math with exponents, if the exponents are the same, what do? They just cancel off. Okay? But if you're not comfortable with that, just enter it this way. You can go 7.2, okay, E23 divided by 6.02, E23. All right, so we have 1.196 moles. All right, now that I have n, now I can use the mole equation to get m. So n equals little m over big M. I'm going to multiply both sides by big M, so it's going to come over here. And I'm going to take my 141.94, big M, multiply it by n, 1.196, and get the mass. Which should be 169.76 grams. Okay, questions on that one? Is it pretty formulaic? Like, once you identify which one it is, you just follow the steps. Okay? There's really not much else to it. All right, I'm going to give you a 5-minute break here. 9:36. I'm going to come back and have you work on some stuff from the workbook. In your digital workbook, at the bottom of page 11, okay, you will find some mole equation questions. Right? I would like you guys to work on questions 2 and 3 and 4. For right now, they're the ones that are on the board. Okay, so in number 2, they're simply asking you to calculate the number of moles in the given samples. Okay, for number 3, the mass of the given samples. Okay, and number 4, again, the mass, but this time they tell you the number of atoms. Okay, so you have to do an Avogadro thing with that one. Right, I'd like you guys working on those. Okay, I believe I put the keys in the class work tab, but I will double check that. Okay.